All right, so on the combined gas law homework, what I'd like to do is just give you the answers first. By the way, if you're going to take an extra day to do this, then go ahead, write down the answers, but hide them from yourself and then work out the problem, and then you have the answers to tell yourself whether you're doing it right or wrong. And then I'm going to remind you that we're present and engaged, meaning our phones are put away. Thank you. All right, so we got 1.9 liters. We worked out that problem yesterday. This one is 800 torr. This one's -4 degrees Celsius. Number 4, we have 4 ATM. 1.2 ATM, sorry. This is 22 degrees Celsius. By the way, are you noticing all the answers for temperature and degrees Celsius? All you have to do is take your Kelvin and subtract 273.15. So you still use that same equation. If you want to go backwards, back to degrees Celsius, then you just subtract. Okay, let's see. Number 6 is 275 milliliters. Then we have 540 millimeters mercury. And then lastly, either 544 K or 271 degrees Celsius. Yeah, Caden. Yeah. Yes. Add the 0.15. Is there a problem that someone would like me to show? Should we do one with temperature, like number 3? Number 3. Yeah, let's do number 3. I like it. First of all, please get in the habit of writing this equation. And then I just want to point out, I remember VP as vice president. That is ingrained in my head. And if you notice, if I just by default write it down, do you guys see how I put the V first? But yet on your worksheet it has P1, V1. Does it really matter?
No.
It doesn't, because of multiplication, because of the commutative property of multiplication. So, all right, so I did want to point that out. It does not really matter. Please don't let me flopping it confuse you. I'd recommend on each problem always writing down the equation though. All right, so let's plug it in. So V1 is 2.5 liters. P1 is 600 millimeters mercury. And where's the little line? Oh, it's above here, right? T1 is in Celsius. So I'm going to do a little side conversion here. This is what Caden was asking about. Do I add the 0.15? Yes, please. However, this is the significant place value. So I leave the number raw, unrounded, but I identify for myself where the sig fig should be. The reason, again, is because this is the least precise decimal. So if you did the little dotted line, that's where it would be. All right, so I'm going to put that new value right here. And then my volume is 1.8 liters. This is 760 millimeters mercury. And what I'm looking for is T2. I don't actually do any of the math until the very end. I like to, at this point, cross multiply because I have my variable in the denominator. So I'm going to take this numerator, multiply it by that denominator, and this denominator, and multiply it by those numerators, just so I can clear the fractions. So I now have T2 times 2.5 liters times 600 millimeters mercury, and then 295.15 but that's the significant place. 1.8 liters, 760 millimeters mercury. To get my T by itself, what I do to one side, I have to do to the other. Remember your rules of algebra. If you have stuff being multiplied, you're trying to get rid of it, then you divide. So I'm going to go ahead and divide by this 2.5 liters and 600 millimeters mercury. And I am showing all of my work, and it's really, a lot of labor here to write all of this. But it's important to show all of your work in chemistry because it's almost like proving yourself. It's using evidence to prove your answer. All right, so before I waste my time doing math, I recognize that those all cancel. That's easy. But over on the right-hand side, check your units. So my liters cancel with liters. My millimeters mercury cancel with millimeters mercury. I'm left in units of K, which is temperature. And oh good, I'm actually looking for a temperature. And when I do this math, you have 295.15 times 1.8 times 760. Remember your calculator, you have to hit divided by 2.5 and then divided by 600. And what you get is 269.1768. This is units of Kelvin, but I need to remember I have to look at sig figs. So I've got 3 sig figs here because remember I reminded myself where that was. 2 sig figs here. This is ambiguous. So remember ambiguous numbers, I just go with the least amount. This is 2 sig figs, and this is identified as 2 sig figs. All right, so I need to round to this place. Careful, that's not 27. That's 270K. All right? So I think the answer that was -4 degrees Celsius on the answer key, they didn't round it. They went ahead and left this number raw. They subtracted the 273.15.
That's how they get the -4.
Yeah. Because what do they get? What you get is -3.9732. Yeah. Yeah. So then it was -4 degrees Celsius. So this would work, or this would work. Yeah. Okay. Those are, I feel like the ones with temperature are the most difficult, especially if the T is the unknown, just because it's extra algebra steps. It's, doing the cross multiplication, and there's lots of room for error right there. Yeah, Brian. No, not at all. Scientific notation will never fail you. It's just if you did it the wrong value. So are you saying that you wrote 2.7 times 10 to the second power K? Yep, that's actually really nice and clean because that's showing 2 sig figs. Versus this one, maybe you could identify, like for sure that 7 is the significant place value.